What's the one mistake everyone makes when setting up VLANs? Hint, it's why your devices can't talk across switches. In this video, I'll reveal the secret trunk mode trick that connects your VLANs properly, show you why switchport mode access alone isn't enough, and how to fix that frustrating encapsulation error in seconds. Watch now, your VLANs will finally work the way they should.
In this topology, we have two PCs that are simply connected to a switch. We will start by analyzing the configuration of the VLAN, making a show VLAN on switch A. The VLAN1 is the default VLAN, and you see all the active interfaces assigned to it. The information you see here is not stored in the running-config file, nor that of the startup-config, but in a file called vlan.dat, which is located in the flash memory of the switch. If you want to delete VLAN data, you will need to run the delete flash vlan.dat command. Both PCs are part of the same subnetwork and are able to communicate correctly with the switch's default configuration. We will now create a VLAN that will bear the ID number 10. The vlan10 command allows you to return to vlan10 configuration mode. If it doesn't exist, then the creation is done automatically. We then give it the name PC with the name command. Giving a name to a VLAN is not mandatory. Now, if we relaunch the show VLAN command, we can see that the VLAN10 is well in the vlan.dat file. On the other hand, no port is assigned to it. So we're going to add fast Ethernet ports 0/1 and 0/2. To do this, you have to connect to each of the interfaces. Then set up the access mode with the switchport mode access command and place the interface in the VLAN you want with the switchport access VLAN command. Both PCs are now part of the VLAN10 and can communicate again. The show interfaces switchport allows us to display a lot of information, such as the type of interface and the number of VLAN to which it belongs. We will now add a switch, which will be called switch B, on which we will move the PCB. Now this is what our topology looks like. As with switch A, you have to create the VLAN10 that will also be called PC, and assign it to the port so it is connected to the PCB. The next step, so that PC A and B can communicate together on the same VLAN, is to create a trunk link between the two switches, to circulate the tagged frames of VLAN10 from one switch to another. Here, in this example, we see that the command switchport mode trunk is rejected on both switches. If we want to change the interface to trunk mode, we will first have to change the type of encapsulation on the two switches. To see the various options that are offered to us, we will execute the command switchport trunk encapsulation, followed by a question mark. We see that it is possible to choose between .1q and ISL. The type of negotiate encapsulation is the default mode on the switches of this example, but this is not the case for all switches. The ISL type is a Cisco protocol that is not interoperable with other manufacturers, which is why we still instead use the type 802.1q, which is compatible with most switches. And now, we can restart the switchport mode trunk command on the interfaces between the two switches. We can confirm that we have a trunk between the two switches by making a show interfaces F A0/48 switch port on the two switches. The operational mode is .1Q, and a ping from PC A to B works perfectly. PCs A and B communicate correctly through the trunk link. If now we do a show VLAN on switch B, we notice that we do not see the port FAO/48. Well, this is completely normal, because this command only displays interfaces in access mode. To display those in trunk mode, you need to use the show interfaces trunk command. This particularly useful command lets us display interfaces that are in trunk mode, the type of encapsulation they use, 802.1q or ISL, as well as the native VLAN. In this example, we see that VLANs from 1 to 4094 can cross the trunk link. For security reasons, we will limit the number of VLAN that cross this link. The first order removes the VLAN from 1 to 4094, and the second adds the VLANs from 1 to 50. And if we restart the command, show interface trunk of the interface 0/48, only VLANs from 1 to 50 are now allowed to transit on the link. If we do a show interface FAO/2 switch port, we see that the port 0/2 of switch B is well in access mode.